Hi, everyone, and welcome to this episode of the Current Executive Insights. I'm Richard Interrante, and I'm the Global Technical Director here at Future Electronics, focused on embedded processing technologies. Not long ago, I was actually a guest on this podcast talking about the topic of field programmable gate arrays, or FPGAs. And one of the things I talked about was how they're often compared to like a box of Lego bricks. Because with the resources inside an FPGA, you can literally design just about anything that you want with your circuit. Today, you could even design with system-on-chip FPGAs, which not only provide the flexibility of a programmable logic matrix, but you can also now design with processing cores. And those come in handy in applications where you're running real-time applications, or maybe running Linux applications, for example. And FPGAs are also offering more advanced layers of security today for both design and data protection. Here's a simple analogy. Let's say you have a journal or a diary, you want to keep it secret, let's say from your curious little brother or sister. You could put a padlock on it, and that way only the person with the key can get in. But you can argue, maybe with a little bit of brute force, you can get around that. So then maybe with the contents, maybe you write the contents in a secret language that only you know. Again, maybe with a little bit of cleverness, maybe somebody can get around that. So maybe you take the whole journal or diary, you put it in a locked safe that has alarms on it that lets you know if somebody tries to tamper with it. So it's just a simple analogy, but there's nothing trivial about FPGAs that have advanced security features like these. And with the flexible compute power needed for today's intelligent edge applications, and on top of all that, operate at very low power and very high reliability. So that brings us to Microchip, who's one of the leaders in FPGA technology. And today I have the pleasure of speaking with Bruce Wire, who's the Vice President of Microchip's FPGA business unit. Bruce, thanks so much for spending time with me today to share your insights.
Oh, thank you for the invitation, Richard.
Absolutely. Well, let's start with your role at Microchip, Bruce. So, Microchip is a very large company, right? Offering full system solutions that cover pretty much everything you need for design: microcontrollers, microprocessors, and clocks and timing. I know your focus has been on FPGAs, Bruce. So why don't we start by having you describe to our audience a little bit about the BU that you're leading.
Great. Again, thank you for inviting me today, Richard. I've been leading the FPGA business unit at Microchip for the past 10 years, and we've had a common vision throughout that entire period, which is to enable our customers to innovate by offering the most power-efficient programmable solutions. And our mission is to really make sure that we have a clear differentiation, not only in that area, but also in reliability and security. And we measure that by being twice as power efficient as the competition. And we have it very fundamentally designed into our architecture from the ground up to be capable of doing that, along with the premier solution in security and reliability as well.
Excellent. Well, I appreciate that overview, Bruce. And I know that you're aware that Future has invested in a global team of FPGA specialists who assist customers with FPGAs from concept to production. And our engineers have been working with Microchip for quite a few years now. And I know that one of the things we hear from customers is that they always appreciate the innovations that Microchip has brought to the market. One of the most obvious ones is RISC-V processors. They're pretty well known today, but Microchip has been a very early adopter in offering them commercially within your FPGAs. So I know there have been decisions like that one that you've made that have really separated you, I think, from the crowd, and also some acquisitions and things. Maybe you can kind of speak to some of the decisions and actions that you've made that have differentiated Microchip even further in the market.
Great. I really need to start back with the actual fabric itself at first. Most people realize that FPGAs are typically built out of SRAM memory arrays, and that's how you program your logic. But one of the challenges with SRAM is it's continuously needing to be refreshed. So you're always burning power if you're using a block or not, and it's in a dynamic state. Microchips FPGAs are built off of non-volatile memory. So our cells are much lower power consumption because they're not continuously being refreshed. So in a standby current, we can be up to 1/10 the power of an SRAM cell. And then we also design all of our mid-range FPGAs or PolarFire FPGAs, all functional blocks really designed as well to be low power. So our transceiver technologies burn half the power because we're focused on the mid-range and not taking a high-end product and rippling it down. So everything, all aspects of our product are, how do we differentiate in the market and have a sustained differentiation between every generation? You brought up a great point of, we chose RISC-V, which was not a typical approach at that time, which a lot of the market was in ARM processing at the time. But the beauty about RISC-V is not only as an open ISA, but we also had access to the architecture. So we made a fundamental decision that we wanted an architecture that was capable of doing asymmetric multiprocessing. So when we have our quad-core processors on board, they can be used for Linux-type operating systems, or they could be used for bare metal in real time. And each of the four processors independently can be used in either plane. And we also have a fifth processor on board, a housekeeper, a microcontroller, so that we have all four of those processors dedicated to either Linux or real time. And if you think about that at an application level, and the context, we have a very low power consumption FPGA fabric, and FPGA fabrics are great for AIML as well. Think about an application like a drone or possibly a robotic application. In the drone, you could be running the real-time operation with one or two processors. You'd have 2 or 3 processors remaining for real-time applications. FPGA fabric, our fabric supports 100,000 RPM brushless motor control. We've got industry's best security. Because we have the lowest power consumption, you have better flight time. So all aspects of that product can be enhanced and really broadly controlled by an FPGA.
I appreciate that, Bruce. I mean, so with all of that behind you now, kind of looking to the future, right? I mean, FPGAs, I know we've all heard about the applications that we're starting to see FPGAs in, and they're so diverse. They're consumer, they're industrial, they're space, and so many different applications in between that. Anyone following Microchip will know that you've had a really active few years in terms of announcements like PolarFire 2, the new 64-bit RISC-V microprocessor family. Can you share a little bit more about those developments and how they align with the mega trends that you're focused on looking forward?
Absolutely. So we've had quite a few number of announcements, and they really bridge our current technologies of PolarFire and PolarFire SoC. PolarFire SoC has the embedded RISC-V processors, and it's bridging to our next generation of PolarFire 2. And I'll start with the announcements of we've had a couple of AIML acquisitions on the technology side. A number of years ago, we bought a company called Vector Blocks, which brings in the process of how we bring this technology to market, the design flow for our customers. But recently in May, we announced the acquisition of Neuronix AI. And Neuronix does a technique called sparsity, where anytime you take a full neural network model and you optimize it down to this specific application you're using, you prune off a lot of branches of that original model. And you always implement a null in that spot, a 0. And the beauty of sparsity is they remove all those nulls before you go through the math. So it dramatically, and Neuronix specifically target FPGA fabrics for this technique. So it dramatically reduces the footprint within the FPGA, which saves you a lot of money, but it also increases performance and dramatically lowers power consumption. So that can be applied to PolarFire and PolarFire SoC, as well as our next generation PolarFire 2. That's an example of some of the technologies we're making available today for existing architectures. PolarFire 2, we've announced in the market that we'll be shipping it next year in calendar 25. And again, we double the power efficiency from PolarFire to PolarFire 2. And one of the interesting things competitively is everyone recognizes that power efficiency is really important, and everyone compares to each other, but no one compares to PolarFire. And the reason for that is because PolarFire is the best in the industry today. It's been in the market for 7 years, and it's still by far the most power efficient architecture in the market because of its non-volatility and how we've designed it. And And PolarFire 2 is going to double that power efficiency again. It's going to double the performance. So we have a much broader reach in the market from an application space standpoint. And it's going to be twice as dense. It's going to be twice as large of an array. So we're really excited about the capabilities of our products and also the requirements in the market. As the intelligent edge is a well-known entity, but now it's becoming the intelligence aspect is really expanding broadly. Yeah. So the need for FPGAs is growing dramatically across the entire spectrum. So we think it's a very rich environment for us to play in, and we're really excited about power efficiency and security are very central to the needs of the intelligent edge.
Right. And you mentioned security, which is a perfect segue to the next question. At the beginning of the conversation, we talked about the importance of security. And, you have to protect your design and your data, and you have to make sure that you're working with hardware you can trust. Now, Microchip has a multi-layered approach to security. I think of secure elements, platform root of trust controllers. You even have MACsec PHYs, to protect data moving back and forth. So there's lots of layers to it. And on the FPGA front, your products are definitely no exception with the defense-grade security that you offer. Can you describe the FPGA BU's high-level approach to this important topic of security with respect to the intelligent edge?
Yes. Everyone recognizes the need for security, but a lot of people really look at bitstream. And they say, how do we secure the bitstream so that cannot be reverse or how do we encrypt it and things like that. And the reality is yes, we have an advantage there because we're non-volatile and you don't have to upload bit streams. But we really believe that security fundamentally starts with hardware security. You need to make sure that the product is not capable of being tampered with. We've had a very strong history in aviation and government defense type applications. And you do not want your IP to be able to be extracted from an FPGA because the FPGA many times is really the biggest differentiation aspect of the end customer's design. Right. So we have anything from meshes on board so they cannot be probed to resistance to side channel attacks, all aspects of physical security. We also enables to have it programmed in a secure environment, hardware secure modules, such that you can have it offshore programmed and you can be serializing every individual device, if there's overbuilds or not, if there's cloning taking place, et cetera. If there's a problem in the field, in a war zone, for instance, and one of your secret applications is going down behind enemy lines, you can brick the whole product. You could zeroize it. There's no design left within it, and you could brick it so it's never accessible again. And there's 30 different anti-tamper sensors in our current product, and you can have multiple levels. You can simply say, I want to reboot it, I want to brick it, I could do anything in between. So there's a tremendous amount of physical layer security that introduces IP security, and then it moves back up to data security. And a lot of people in the industry are simply talking about data security. So that's a very different approach to what it means to have a secure design, secure IP, secure product in the marketplace. And it's extremely important for any real-time application as well, like automotive, autonomous vehicles and anything that could create a dangerous environment, a robotics-based environment, et cetera. It's important to have the appropriate level of security in place.
Interesting. I appreciate that perspective, Bruce. The last question I wanted to talk about today is the ecosystem. The support that developers can expect when they're working with your FPGAs. So obviously those tools and partnerships are important to help customers achieve success. So are there any elements of that ecosystem that you'd like to highlight?
Well, when you look at the embedded world, obviously you have to have a complete ecosystem. And Microchip has a continuum of standard platforms that support all aspects of anything from microcontrollers to microprocessors, right? But what's interesting, and we recently announced our PIC64 64-bit microprocessing solutions. And when you think about ecosystem and commonality, we extend all the way down into our fabrics, actually. So, for instance, PolarFire SoC, we introduced the quad-core asymmetric processing. And we've taken that same technology, and it's available now in a PIC64 standalone microprocessor device. But yet that device is pin compatible with the PolarFire SoC solution. So if a customer wanted to modify that design and gain more differentiation, they could start with a lower cost PIC64 GX device and then move up into the PolarFire SoC. We've also pre-announced, a couple of years ago, we announced the fact that Microchip is designing partnership with JPL and NASA, the high-performance spaceflight computing platform, which will be an octal platform based on RISC-V also. And we've now announced that we have a PIC64 HX, which is a commercial version of that. So you'll have commercial all the way to space level applications. So to us, ecosystem, people think about the software ecosystem and or the partnership ecosystem. We think it's the entire environment of how customers go to market. Yeah. So absolutely, we have a huge focus on the entirety of the ecosystem, inclusive of compatibility between our products all the way up through partnerships.
Interesting. Bruce, I can't thank you enough for spending time with me today to share your thoughts. Just all very interesting, and congratulations on the progress that your business unit has made. It's just been tremendous. I also want to thank our viewers for watching. If you're starting a new project, you're interested in taking a look at Microchip's line of FPGAs, or maybe one other product from their wide list of technologies, Future Electronics has the engineers available to help you. You could reach us by sending an email message to shapingthefuture, that's all one word, shapingthefuture @futureelectronics.com. It's here on the screen, shapingthefuture @futureelectronics.com. Thanks for joining us today on the Current Executive Insights, and we look forward to seeing you again next time.